Welcome back. Let's talk about dividing rational numbers. Let's say we have the following fractions. We have a over b, that's an a, it's not a 9, it's an a. We have a over b divided by c over d. Okay, dividing rational numbers, don't get excited here, it's actually pretty straightforward. There's just a simple rule that we apply. And basically how I describe it is, when we're dividing rational numbers, we don't ask why, we flip the second and multiply. Don't ask why. So a over b divided by c over d gives us a over b. Don't ask why, we flip the second and multiply. So we multiply, flip this, c over d, we flip it to d over c. Okay, so let's make sure we got this. We have a over b divided by c over d. We don't ask why, we flip the second and multiply. And multiplying rational numbers is something that we already know how to do. If we need a refresher, go back to the multiplying rational numbers section and for a quick review. But let's move on right here. So multiplying rational numbers, we simply multiply the numerators, multiply the denominators. So a times d over b times c. And that's a general version of our answer. That's what we're going to do. But we want to make sure we get this step right here. When we're dividing, we don't ask why, we flip the second and multiply. Let's look at some examples. Let's start with a simple one. We have 1 over 4 divided by 2 over 3. Okay, so let's keep it simple just to make sure we get it. So we rewrite the first one, 1 over 4. We don't ask why, we flip the second and multiply. Multiplied by 3 over 2. This is called its reciprocal. 2 over 3 is the reciprocal of 3 over 2. But that's neither here nor there. We don't ask why, we flip the second and multiply. And this is something we can handle. 1 times 3 is 3. 4 times 2 is 8. And that's the answer. Now, another way to look at it is if we have a over b divided by, we use the long division bar, or not the long division, but actually the division bar, excuse me, c over d. Here we just flip the denominator. The denominator is our second term. So it's a over b multiplied by d over c. We flip the denominator. So that's the other version of that. Let's look at another example. Let's say we have 2x over 9 divided by 4 over 3y. Okay, so what do? We rewrite the first one, 2x over 9, and we don't ask why, but we flip the second and multiply. Well, the reciprocal is 3y over 4. We just simply flip it. Okay, you'll hear me go in a lot of videos, you'll hear me say we would simplify. I'm a big proponent of simplifying as we go. It makes things, our calculations especially, a lot simpler as we go along. What we can do here, multiplying across, well, not multiplying across, but taking out a factor of 2 across. This becomes a 1, this becomes a 2. Over here, we can take out a factor of 3. This becomes a 1, this becomes a 3. Simplifying as we go. So actually, instead of having larger numbers, we have smaller numbers, usually easier to deal with, especially when we get into larger, fractions. So we have 1 times 1, or we simply have x times y is xy. 1x times 1y equals xy. 3 times 2 is 6. So our answer is xy over 6. Okay, so very straightforward, as long as we have this little rule that we've learned. Let's do another one. Let's say we have a negative y over 3 divided by x over 2y. Okay, so what do here? We rewrite the first one. We have a minus y over 3. We don't ask why, but we flip the second and multiply. So 2y over x. Okay, and this is something we can deal with. So we have a minus y times a 2y, which gives us a minus 2y squared. Y times y is y squared. 3 times x is 3x. And that's our answer. Let's do a couple more, just to make sure we get this down. Next we have x squared divided by 3. We're going to divide this by 11. Okay, since a whole number is simply just a rational number with a denominator of 1, let's rewrite it for clarity. Let's just put this over 1. I like to, if we're multiplying or dividing especially, I'd like to rewrite the whole number as a rational number so we can have two rational numbers. This makes things simpler. So what we do is we rewrite x squared over 3. We don't ask why, but we flip the second and multiply. Flipping a whole number is easier, or flipping a rational number is easier than flipping a whole number. It's just easier to see that we have 1 over 11. And then we can multiply straight across. X squared times 1 is x squared. And the denominators, 3 times 11 is 33. We have x squared over 33. Let's take a look. Let's see, we have 1 over 3. This is our next example, divided by 2 times minus 3y. Okay, so we actually have an expression for our second term. So let's take care of distributing the 2 and then we can write the reciprocal, being careful with our negative sign. So let's rewrite the first one. Divided by, distribute the 2. Since this is a whole number, we're just going to multiply this rational number by a rational number. 2 times a minus 3 is a minus 6. 1 times y is a y. Just a y, is a y. Now remember, when we have a negative rational number, the minus sign always goes with the numerator. So this is actually a minus 3 over y. Now this is a rule that you'll basically get used to the more you see it in practice, but the minus sign always goes with the numerator, because essentially, if we look over here, we have a minus 1/2. We can actually bring out this minus sign and have a minus 1/2. And what we do is we're multiplying this rational number by minus 1. So what do we do when we're multiplying by minus 1? Well, we multiply the numerators. Minus 1 over 1. Minus 1 is just a rational number, minus 1 over 1. We multiply the numerators. We have a minus 1. 1 times 2 is 2. So, not to insult your intelligence, just doing this on the side, but the minus sign always goes with the numerator. So we write it like this. Minus 6 over y. Now when we're dividing, we rewrite the first one. We don't ask why, but we flip the second and multiply. So instead of minus 6 over y, we have y over minus 6. The negative number goes with the term. We're flipping the entire fraction. So now we multiply across. We have y over minus 18. And we can simply rewrite this as a minus y over 18. When the minus sign is in the denominator, it actually really doesn't matter. This is our answer, and we can rewrite it as a minus y over, all these answers are correct. We can have a minus y over 18. We can have a minus y over 18, or we can have a y over minus 18. All three of these answers are essentially the same. They're just written differently. So be sure to check with your professor or your instructor to make sure which version they would like, which form they would prefer your answer to be in. But these are actually all equivalent. Let's do one more. Let's say we have a minus 9 divided by 3x squared y. Okay. Let's go ahead and rewrite this whole number as a rational number. And let's rewrite this the second term as a rational number. When we're dividing, Whole numbers are easier to be rewritten as a rational number, because when you're flipping something, you're essentially treating it as a rational number. So even though we're not flipping this, we need to flip it later because we're dealing with this as a rational number. So let's write both of them over 1. Make things a little simpler. So we have a minus 9 over 1. We rewrite that. We don't ask why, but we flip the second and multiply. We have a 1 over 3x squared y. Now, of course, we can simplify as we go. We can have a factor of 3 in these two fractions. We have a 1 and a 3. We took out a factor of 3 out of 3 and 9. So now we have a minus 3 times 1, multiplying the numerators, is a minus 3. We have a 1 times 1x squared y, which is just x squared y. There you go. Let's look at a quick application. All right, let's look at Newton's second law. Newton's second law is actually the first big law that you'll actually hear a lot of. You'll hear it in physics, which I'm a big proponent of taking physics. Physics is pretty much math in motion, is what I call it. Newton's second law states that the force of an object is equivalent to the object's mass multiplied by its acceleration. So the force equals mass times acceleration. This is Newton's second law. So what we want to do is calculate the speed of a ball in meters per second squared that weighs 1/8 of a kilogram when 6 1/16 newtons of force is applied to it. So let's see, we have force is 6 1/16 newtons. We have a mass. The mass of the ball is 1/8 of a kilogram. And we want to know the acceleration in meters per second squared. Okay. We're actually running out of room here. Alright, so what we do is we're going to plug this in. Let's actually manipulate our formula really quick. We want to solve for acceleration, so what we're going to do is we're going to divide both sides by mass. Since we're doing the same thing on both sides, we're actually not changing the problem. But we want to isolate acceleration. So m cancels with m, and we have acceleration equals force divided by mass. Just simply rewrote it in this division sign instead of the bar. So force divided by mass. This is a division sign. Okay, so now let's go ahead and plug in our numbers. We have acceleration equals our force, which is 6 1/16 newtons. And we have our mass is 1/8 of a kilogram. Okay, so we basically are dividing two rational numbers. So we need to convert this mixed number into a rational number. So basically we will have acceleration equals, I believe it's 101 over 16. We just converted this mixed number into that's actually an improper fraction. And we don't ask why, but we flip the second and multiply. So 1 over 8 becomes 8 over 1. And now we can multiply straight across. This will give us 808 divided by 16 times 1 is 16. And this will actually simplify to 50 and a half, or 50.5. And our acceleration is 50 and a half meters per second squared. This is our answer. Okay, so when the speed of a ball that weighs 1/8 kilogram, it has a force applied to it of 6 1/16 newtons, and we found that the acceleration of that ball would be 50 and a half meters per second squared. This is Newton's second law, which pretty sure we'll talk about later on in the algebra course, and later on we'll maybe do a physics course and we'll talk about that, but it's really, really neat. We're talking about math in motion, and it's really cool to see the fruits of the labor when you're learning all this mathematics and you're wondering what you're going to use it for. Well, when you get into physics, it gets really, really exciting. So what did we learn here? Well, dividing rational numbers, we need to memorize a rule. And it basically goes like this. You don't ask why, but you flip the second and multiply. You flip the second rational number, the second fraction, and you multiply instead of dividing. Multiplying is much more simple than dividing. It's much more straightforward. So it's easier to rewrite it like this than actually go through the division, which is quite laborious. But I'm out of time, and I'll see you soon.